need a quick way to generate concise summaries without building custom NLP pipelines or managing API keys. You'll see how to create a FastMCP tool that delegates summarization directly to the client's LLM. Just pass in the content, and the tool handles the rest. The pattern uses ctx.sample to offload the heavy lifting, so you only need to define the prompt and return the response.
FastMCP tool. Async def generate summary, content, SDR ctx, context, SDR. Generate a summary of the provided content. Prompt equals F. Please provide a concise summary of the following content. \n content. Response equals await ctx. Sample prompt. Return response text.
This demonstrates the LLM delegation pattern, where complex natural language tasks are offloaded to a language model while your code maintains control over the workflow. The pattern creates a clean separation between your application's core logic and AI-powered text processing, treating the LLM as a specialized service rather than embedding it in your codebase. What makes this distinctive is how it preserves your function's simplicity while enabling sophisticated text operations through a single ctx.sample call. The pattern works by encapsulating LLM interactions within a standardized interface. Your tool defines the task structure and requirements through the prompt, while the framework handles the actual LLM communication, response parsing, and error handling. This creates a declarative approach where you specify what you need, a summary, analysis, etc., rather than how to achieve it, keeping your code focused on orchestration rather than implementation details. This approach matters because it solves the integration complexity of working with LLMs. Instead of managing API calls, token limits, and response parsing, you work with a consistent interface that adapts to different LLM providers. It's particularly valuable when building AI-assisted tools where you need to combine deterministic logic with generative capabilities, or when you want to make your tools provider-agnostic for future flexibility. Let's break it down line by line.
FastMCP tool. Async def generate summary, content, SDR ctx, context, SDR. Generate a summary of the provided content.
The @MCP tool decorator marks this function as an AI callable tool in FastMCP. It automatically generates an API schema from the type hints and docstring, exposing this function to AI models for execution. The ctx context parameter is mandatory for all FastMCP tools. It handles logging, progress reporting, and provides access to the execution environment. This pattern ensures tools integrate seamlessly with FastMCP's runtime system.
Prompt equals F. Please provide a concise summary of the following content. \n content.
This constructs the prompt string for the AI model, combining a fixed instruction with the dynamic content. The F-string format ensures clean separation between the instruction template and user-provided input, preventing prompt injection while maintaining readability. This is the standard pattern for FastMCP tool prompts. Instruction first, content clearly delimited with new lines.
Response equals await ctx. Sample prompt.
This delegates the prompt to the AI model through FastMCP's context interface. The await ctx.sample call handles the async AI interaction, returning the generated response while maintaining proper logging and progress tracking. All FastMCP tools should use this pattern for consistent AI integration.
Return response text.
This extracts the AI-generated text from the response object. The FastMCP contexts.sample method returns a structured response, but only the raw text content is needed for the summary output. FastMCP context integration. The context object transforms simple functions into interactive AI workflows by providing progress reporting, LLM sampling, and resource access through a single parameter. Always await context methods. Missing await silently breaks execution flow and creates debugging nightmares. This pattern turns procedural code into real-time collaborative systems without changing the function signature.
The context that asks for nothing contains every possible answer.